Alright, this video is for discovering exponents, worksheet 2-2. In this video, we'll be just going on over this rule, the quotient rule, and you'll see I give optional ways of writing it. That depends on whether or not we've gone over negative exponents or not yet. So either way is you're able to write it that way. Okay, for this first set of three, please pause it and grade yourself. If you're not in this class but would like to take these skills live, see the description and click the link and you'll go to my OutSchool class. So let's go ahead and zoom in and look at these. I'm going to change the color of my pen to blue. Okay, let's do some counting. So we just need to write this multiplication quicker. All right, so our base is 4 because that's what's being multiplied, and I'm multiplying it 2, 3, 4, 5 times, so the exponent is 5. The exponent is how many times we multiply it. Here, the thing I'm multiplying is 7, and I'm multiplying it 3 times. Here, the thing I'm multiplying is 8, and I'm multiplying it 1, 2, 3, 4, 5, 6, 7, 8, 9 times, so the exponent is 9. All right, let's go on to the quotient rule. So the quotient rule says if I divide, I subtract the exponents. All right, so in this one, it would be x 3 minus 2, which is either x is just an x left, or you could put x to the first power. Remember, I'm not picky about that. This one would just be 5 minus 3. Always remember you take the exponent on the top of the fraction, and that's the first thing in your subtraction because that will change the answer. All right, and then I'm left with x to the second. All right, I'm going to model this one. I did the rule, but I'm going to model the rule on this one. Remember, if you subtract them, you get a 4, but I'm going to model it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7. Cancel. That's this one with this one. Cancel this one with this one, like I'm reducing a fraction. Cancel, 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 and I'm left with 4. I did x's instead of n's. They should be n's. I'm left with 4 unknowns. Okay? All right, now this one's a little tricky because the bigger number is on the bottom. Okay, so if I'm subtracting them, I'm subtracting 3 minus 15, which is going to give me a negative number of negative 12. Okay, and the next one I'll model it. So that is how the rule works. Remember, the first number on the top of the fraction goes first, then the number on the bottom of the fraction, it's second. Now if I was to model it, I'm doing it again. I have 2 y's on the top and 7 y's on the bottom. So if I cancel here, I cancel this one with this one and this one with this one. Now I'd have a domain range error if I didn't put a 1 on the top. Remember, that doesn't break anything because of my identity rule. I can multiply anything by 1. Doesn't change anything. So that leaves me with a 1 on top. 1, 2, 3, 4, 5. 5 y's on the bottom. Okay, and that is how we get that a negative exponent equals a fraction. And we're not really going to talk about it in this class so much, why it can't go over the origin, why an exponent can't go over the origin, because that's looking at the function of an exponential expression. So I save that for a class where I talk about functions. Okay, I do have one called function families, and if you want to take that next, that's really a good class to take next after this. All right, or take logarithms. Okay, so there's an understood 1 here, so 1 minus 12, which is going to give me a negative 11. All right, I think I'm going to model this one. So first, 3 goes into 12 4 times, so I know my answer is going to be 4. Okay, I'm going to have 2 y's on the top and 1, 2, 3 x's, and then I'm going to have 1 y and 2 x's. So if I cancel out one of my y's and 2 of the x's, leaving me just with 4 yx. All right, this one I'm going to subtract. So I have 8q4 minus the 9 on the bottom. X doesn't have like bases with anything. I already brought that to the top, so the only thing left is this 4 on the bottom and the p on the bottom, which is not like to anything. So 4 goes into 8 2 times. Q is going to be -5, x to the third, p is left on the bottom. So I could either write it this way or one of the two ways that I have expressed over here in red. Okay. All right, 10, R10 minus 2, and this is 10 divided by 2. I got to do that math. And T, -2 minus 9. Well, ooh, I have a question wrong here. I must have not seen that negative when I did that. So it's actually -11 on the bottom, or, well, it's either -11 on the top, sorry. It's either 11 on the bottom or -11 on the top. Okay, I made a faux pas there. All right, so 2 goes into 10 5 times. 10 minus 2 is 8. So I wrote this wrong. 12 minus 2 is 10. And -2 minus 9 is going to be 11. A -11. It's adding up my debt. Now I can make that a positive by throwing it on the bottom if I want. Just like they are equal in our modeling, we could do that as well. All right, so explain the quotient rule. It's just, again, just like in our product rule, it's just expanding. It's expanding the multiplication on top and bottom of our division. And then rewriting it, simplifying it. I should put solve because there are times we can solve, or simplifying it. All right, so as long as you have some kind of variation of that, you are correct. So let's do one. Let's do x to the third over x to the second. Well, that's 3 x's a multiplication on top, 2 x's a multiplication on the bottom. If I cancel out, like I would in reducing a fraction, I would be left with 1x. So then they come up with a rule that is 3 minus, is just subtracting, because that's basically what reducing is, and I just get x again. All right, so they've come up with this rule based off the modeling. All right, very good. Keep doing these until you master it, and I'll see you in class.